Good morning, viewers. This morning we'll have a question at hand, and the question says, what is the pH of the resulting solution formed when 25 centimeter cube of 0.1 molar of sodium hydroxide is titrated against 50 centimeter cube of HCl? So we are asked to calculate the resulting solution, the pH of the resulting solution. Now, how do we go about this? First of all, we write the equation. HCl reacting with sodium hydroxide to get sodium chloride and water in the ratio of 1:1. That is our mole ratio. Have that in mind. Now, there are other parameters we have here, something like volume of acid, concentration of acid, volume of base, concentration of base. They are given as volume of acid 50 centimeter cube, concentration of acid 0.1 molar, volume of base 25 centimeter cube, concentration of base 0.1 molar. I want you to note down these parameters because I want to wipe the board for space. Now, how do we calculate the pH of the resulting mixture? Look at the mixture we are told to calculate the pH. Now, knowing fully well that the amount of acid must be equal to the amount of base for the pH of this side to be 7 or to be neutral. Now, all we need to do is to calculate the amount of acid and calculate the amount of base and see if there is any of the solution that is excess. Now, since the ratio is 1:1, it simply means the amount of acid must be equal to the amount of base. Now, we say to calculate the amount of acid from the formula, the amount of acid is equal to concentration of the acid multiplied by volume of the acid. Likewise, amount of base is equal to concentration of the base multiplied by volume of the base. Remember the formula. Now, amount of acid is 0.1 molar multiplied by 50 centimeter cube. Then this centimeter cube we divide with 1000 to convert it to dm cube. Similarly, concentration of base is 0.1 molar multiplied by 250 centimeter cube. We divide it with 1000 to convert it to dm cube. Now, at this point, when you calculate the amount of acid, you have 0.005 moles. The amount of base, you have 0.0025 moles. Now, to check which of these is in excess, this one is smaller, we subtract it from the bigger one. For us to subtract it from the bigger one, we have 0.005 minus 0.0025. We have 0.0025. So that simply means when this base neutralize the same amount from the acid here, this is the leftover of acid in that solution. Now, to calculate the total concentration of this amount in the solution, it has to be, remember that the concentration, formula for concentration says amount all over volume. This is the formula for concentration. Now, if we have this, we have already gotten the unneutralized hydrogen ion. Look at it, the concentration of unneutralized hydrogen ion. Now, that unneutralized hydrogen ion is in a solution that contains 50 centimeter cube of acid and 25 centimeter cube of base. That is the volume, the total volume. So for us to calculate the concentration of that unneutralized acid in this volume, we'll have that the unneutralized concentration will now be the amount of acid that was not neutralized. We'll have 0.0025 all over. This volume were 25 plus 50, that is 75 cm cube. We divide it with 1000 to convert it to dm cube. We have 0.075 dm cube. So this number now, we bring it here 0.075. Then the concentration of the mixture will now be, the concentration of the solution will now be 0.033 mole. Now, since we have gotten the concentration of the solution to be 0.033 mole, now we look for the pH of this hydrogen ion concentration. This is the hydrogen ion concentration that we are not neutralized. So to calculate the pH, we'll go to the formula where we'll have that pH is equal to minus log of hydrogen ion concentration to base 10. Now, having this as the concentration, we convert it to standard form. We have 3.3 times 10 raised to the power minus 2. This point move 1, 2. We have 3.3 times 10 raised to the power minus 2. Now, this is the hydrogen ion concentration. We substitute it in this formula. We have our pH to be equal to minus log 3.3 and 10 raised to the power minus 2 all to base 10. So to expand this, we have minus log 3.3 base 10 plus minus log 10 raised to the power minus 2 base 10. To expand further, we'll have minus log 3.3 base 10 plus 2 times 1. Then to sum it up, the pH is equal to, if you trace minus log of 3.3 to base 10 and then minus log of 3.3 base 10 plus 2, that should give you a pH of about 1.48. That's the pH of the resulting mixture, making it very acidic. Very acidic. Why? Why is it so? Because since the ratio is 1:1 and 0.0025 neutralize 0.0025 of acid, then unneutralized acid was 0.0025. Now what it means is that this one that neutralizes this has cancelled. So this is the amount of hydrogen ion that were present unneutralized. And when we check the concentration of this amount in 0.75 dm cube, it gave us 3.3 times 10 raised to the power minus 2. So when we use that concentration, we arrive at 1.48. So the solution is very acidic. Very acidic. The solution is very, very acidic. Thank you.